Hi, everyone, and welcome to How Trimble's Positioning Technology Aids Driver Assistance and Autonomy. This automotive news webinar is brought to you by Trimble. We're delighted you're with us for this presentation. I'm Emma Hancock, host, strategist, and moderator at Automotive News. Before I introduce our speaker today, a navigation tip. We encourage you to ask questions at any time. Just type them into the Q&A box on the left side of the webinar window and then hit send. I will steer your questions to our speaker toward the end of the session. Today's speaker is Louis Nastro, Director of Strategy and Marketing at Trimble On-Road Autonomy Division. Louis has a deep background in GNSS/INS systems, sensor fusion, and system integration expertise. Over the last 20 years, his experience with autonomous vehicles spans from early DARPA initiatives to off-road and on-road autonomy projects with a diverse set of clients and use cases. And now I'll turn it over to Louis to get us started.
Thank you very much. Good afternoon, everyone. It's a pleasure to be with you to discuss how Trimble positions delivering technology crucial to driver assistance and autonomous vehicle systems. So what I'd like to cover off today is starting off by discussing some of Trimble's systems and how that's migrated into fully autonomous solutions, then touching upon the evolution of the technology and some recent developments when looking at worldwide standards. With that background, I'll be outlining our positioning ecosystem and not only how it provides significant value from a testing and pre-production standpoint, but also scales to provide a flexible solution for deployment in all types of on-road vehicles. We will then transition to performance and touch upon what we mean by safety, integrity, and the relevance of absolute positioning, and ending with what are the key benefits in choosing Trimble as a partner. Just like to break before we get into the content and ask a survey question to the audience on who is actually working with a positioning partner. And I believe if you just click the surveys tab, you can answer that question. So I'll just give you a little bit of time to do that now. Excellent. Thank you for that. So just as a brief introduction to Trimble as a company, it was founded in 1978 solely on GPS technology, mostly for the survey and agriculture industry. But over the last 45 years, it's grown into a diversified company with customers worldwide. So while our strength continues to be positioning technology, Trimble's growth is focused on leveraging geospatial data in new and innovative ways. We basically say it's turning the physical into digital representation. So merging very precise position data with sensors, be it LiDAR, camera, radar, et cetera, to not only locate assets, but embed them into critical customer workflows and aid in extracting relevant data-driven insights from that, which provides a quantifiable ROI for our clients across a number of different industry segments. So Trimble has a deep commitment to innovation with 15 research and development centers worldwide, and they span a whole host of different technologies and investing roughly $500 million in developing new technologies every year. How we're organized as a company, basically we serve 4 core markets today, and that's geospatial, construction, agriculture, and automotive heavy truck, which have all seen significant growth, owed in large part to the broader corporate strategy, which connects users, data, and workflows across their entire industry life cycles. So while our hardware and software are the backbone of how we deliver solutions, it's the insights and connectivity which are the key value drivers to the clients. This has enabled the tremendous impact of our technology in the hands of users worldwide, which provide scale and efficiencies which people have never seen before. What is most germane to our discussion today is how we've taken that approach on road And we recently achieved a significant milestone with our partner General Motors in achieving 34 million hands-free driven miles with Super Cruise equipped vehicles. So this turning the physical into the digital and looking at the insights that we can get from a lot of our test data has allowed us to identify things like corner cases, et cetera, to understand how we can better our product and tailor it to specific use cases for different markets. So now I'd like to discuss a little bit about our legacy in autonomy. Uh, Autonomy is nothing new for Trimble. We've had a long history in systems automation or vehicle automation, but keeping a driver or operator in the loop. And that history in automating systems, we've leveraged that into developing our current generation of autonomous solutions. So our first efforts in vehicle positioning, you can trace it back to 1992 with Pioneer on the automotive side, and with the first auto grade and auto steering systems for off-road that was introduced in 2000. In 2005, we were directly involved with our first autonomous vehicle programs with Carnegie Mellon University at the DARPA Grand Challenge. And in 2007, Trimble GNSS inertial technology helped power the top two teams to win that competition. So that experience really kicked off our efforts in autonomy from a precise positioning sense, but also incorporating a lot of other technologies, which I'll get into later in the presentation. It really informed our insights on how to develop better solutions for automotive OEMs and providing solutions on the off-road side as well. So all that effort culminated in 2021 with us introducing autonomous sprayer and tractor programs with Horsch and Monarch Tractor. I will speak about absolute positioning more later in the presentation, but I would also highlight here our partnership with IHI in Japan, which is another Trimble first in deploying our map-based localization technology, which provides decimeter level performance in all operating conditions. So I'll transition to, why is precise positioning important? So precise position requirements have evolved from convenience features. So yesterday, when, what road am I on, to what lane am I in, and progressing further when we're actually talking about fully autonomous features. So from finding a local coffee shop to now having to precisely locate the vehicle, not only in the lane, but which lane out of a multi-lane highway. That's a safety critical application. So we see a number of different companies and different use cases requiring different levels of automation. And that's why we approach every client engagement on their terms. And this requires us to tailor even though the methodology is the same, the approach that we take for every client engagement is different, and tailoring it depending on the sensor set that they want to use or the operating environment is critical. So let me provide an example. When I was involved in, my first autonomous vehicle project, it was in the mining industry. Some clients want to do an incremental build towards autonomy. So ADAS is that intermediate step, but this client here, the end state was immediately a fully autonomous vehicle. Therefore, given the absolute positioning requirements, we provided a specific position orientation system which could provide decimeter level results in the total absence of GPS reception and bridge outages for an extended period of time. So the approach was clear, but other applications such as ADAS or hybrid on-road, off-road requirements required a very specific approach using position augmentation. So things like map-based localization or LiDAR or cameras are crucial in bridging those extended outages, and components which can be deployed cost effectively on passenger vehicles is obviously of paramount importance. So as the function set for ADAS increases, so do the complexities of deploying a solution. And that's why it's really crucial to have a partner which has a number of technical capabilities that they can bring to the table. So from the previous slide, as we see the progression from positioning required for convenience features all the way to full autonomy, in order to scale the technology successfully, we take a GNSS and IMU chipset agnostic approach. working in concert with that OEM or tier one for the application of our precise positioning engine to provide accurate localization. There's a lot of consultation that happens up front to understand what the current and future requirements are and how to ensure that what is being built has longevity. So from a safety and reliability standpoint, I'll go a little bit more into detail later, but offering an ASIL rated solution with full integrity monitoring is crucial to ensure that we're meeting the current and future requirements of that customer's technology roadmap and expand and enhance that functionality. So that extended functionality requires things like, vehicle to vehicle or vehicle to infrastructure communication in order to coordinate and deconflict movements of different vehicles. So absolute positioning and things like timing are critical in this process, in addition to using vision-based techniques for navigation when the position accuracies can degrade when transitioning from environments, for example, such as highway and city driving. So I would also add that it's not just about the onboard precise positioning engine, but the correction service that's utilized, which gives a true end-to-end positioning capability. So it's a precise positioning engine and our service called Trimble RTX, which is an ASIL B rated precise point positioning solution. And it has full integrity monitoring in order to certify that the position broadcast is correct. So global automotive OEM programs obviously require a solution which is scalable and available worldwide. And RTX, when coupled with our positioning engine, provides the most comprehensive offering for accuracy, uptime, and reliability. So now I'd just like to briefly touch upon what we're seeing in terms of the status of autonomous vehicle legislation worldwide. So over the past decade, we've seen, I guess, a marked increase in legislation outlining the use and testing of autonomous vehicles on public roads. While automotive bodies such as, for example, the Society of Automotive Engineers and others will make specific technical recommendations outlining hardware and software requirements in order for something to be certified, we see specific legislation as a good thing for this nascent industry. So with standards and regulatory frameworks, just like the formation of the Federal Aviation Administration, we see the same thing happening here. And what's certain is what's certain in this process is reliability and redundancy, which means absolute positioning is a 100% critical deliverable in this process. So what will be required for enhanced ADAS and ultimately autonomy is a combination of technologies which will form what I would call a data-rich backbone, if you will, so that the vehicle can interact in a dynamic environment successfully and perform, against one day universally adopted standards, which level the playing field in terms of performance. So the disparate efforts that we see today are a good first formative step in defining standards, but we still have a long way to go. What I believe what we'll ultimately see is specific sensors and sensor fusion requirements defined, outlining things like minimum equipment to operate in snow, rain, heavy traffic, etc., and reliability and repeatability metrics for that country or operating environment. The one technology that can be used worldwide currently is an ASIL-rated precise point positioning solution and a precise positioning engine like our ProPoint Go, which can be flexible enough to operate with ASIL-rated chipsets. So we'd like to get into a little bit more of the specifics on what we mean by our positioning ecosystem. So the ecosystem is comprised of a number of different hardware and software elements, which cover all the requirements OEMs and tier ones will have in terms of developing an ADAS solution and ultimately autonomous vehicle platforms. We want to be there from the inception of the program all the way to the delivery of the vehicle to the client. So on the vehicle is ProPoint Go, which is our GNSS inertial precise positioning engine, which is embedded on the vehicle's computing platform with automotive grade sensors. The correction service, as I alluded to before, is Trimble RTX, which is ASIL D rated PPP service for use in real time. We also have what's critical in the process, our ground truthing, testing, and validation systems, which are an integral part of that process. So we have a selection of inertial GNSS reference systems, which have different levels of immunity against multipath and extended outages. These position and orientation systems are critical when testing systems under real world conditions. So I'll just give you an example of a typical test setup would be ProPoint Go running on a host processor and the reference position orientation system operating on the same vehicle. Once a test run is completed, the data can actually be played back on an epoch to epoch basis. So a critical analysis can be performed using our POSPAC software to spot any corner cases and assess, accuracy and performance characteristics of the ProPoint Go engine versus an established reference. So this is the best way to ensure that we're identifying potential issues and understanding things, especially like transition environments that can lead to spurious data, such as entering or exiting a parking structure or being stuck under an overpass in rush hour traffic. The other item that we include in this ecosystem to speed up testing and deployment is our B5000 platform, which allows for rapid integration of the chipset and the ProPoint Go engine into the test vehicle. So this data can be synchronized with the position and orientation system easily to ensure consistent results between the two of them. When it comes to map-based localization, I'll speak to that in a little bit more detail in a few slides. But at this point, I will say that it forms an integral part of the aiding technologies required to enable reliable and repeatable absolute positioning. The MBL process uses a position orientation system with post-processing software to generate a map that can be customized to meet any client requirement. And finally, the importance of our professional services team cannot be understated. In every customer engagement, as I stated previously, there's a lengthy requirements definition process and consulting on various components that we would recommend from one of our reference designs. So if something bespoke needs to be built, as done in accordance with the client's requirements in terms of short, medium, and long-term objectives, we keep that in mind so that the complete implementation, development, and maintenance plan is designed up front. So this is a graphical representation of what I just described and where all the various parts come into the process. What's not included here are more complex factors of a program, such as, how sensor fusion gets incorporated to the system architecture and how the client wishes for us to accommodate that. Typically, we follow the same testing protocols and utilize the same tools. In this way, it makes it easier for us to accommodate more complex use cases and be flexible enough to respond quickly to the changing customer requirements. An example of this would be if an OEM was using a vision-based navigation system and wanted to utilize it as a form of positioning augmentation. Using the reference ProPoint Go and POSPAC, along with other analysis tools that we've developed in-house, a test scenario can be quickly executed and reports generated on how that augmentation system performed against the core precise positioning engine alone and the reference system. So you have all these factors that can be synchronized and played back, even if we haven't developed it and the customer wishes to incorporate something else and see how it's performing relative to, is it aiding or not in real time? So having such a capability not only facilitates that integration and testing, but can provide valuable feedback to them in terms of if the approach is truly going to help or not, and it forms a really good collaborative partnership both ways. In the following slides, I will go into a little bit more detail on the representative parts of our positioning ecosystem. So in the pre-production phase, as I alluded to before, typically in various test vehicles, we will set up the chipset IMU combination in the B5000 test enclosure to facilitate the integration and synchronize that with the pause unit. The production GNSS antenna and two Zephyr antennas for the pause are then integrated. So you do actually have the automotive grade GPS antenna, but we also use these two antennas independent for the reference system to improve the heading accuracy, especially in GNSS denied and low dynamic environments. So in addition to this, the OEM will specify if we have access to things like odometry data and how that will be transmitted to us. And if none is available, we will actually put an external distance measuring instrument or wheel encoder that can be easily installed. So that is a standard part of the integration. The only other parts center around if the OEM would like to test out if we can utilize the data from, let's say, onboard cameras, map, or any other data they wish to utilize, or if they wish to use our implementation of map-based localization. So despite those variables, the test setup and integration are pretty straightforward, and a full team of engineers is on hand to facilitate integration and testing. With respect to sensor fusion, the main advantage is to leverage any a priori data to act as a position aiding source during navigation through difficult environments. So the screenshots that you see there are from Las Vegas, where we were demonstrating map-based localization to several different clients, traversing surface routes, and then actually going into complex underground parking structures to show those difficult transitions that I alluded to before. So we can actually show GNSS IMU channels separately, the full-blown positioning solution of the reference system, to map-based localization, and even include or not include the distance measuring instrument or the encoder. So we can actually both run in parallel so that we can provide a fully uninterrupted solution in any environment and show the client where when one of the systems is degrading, how the other one is actually compensating, and then the blended solution and the individual channels. So this is particularly important, as I mentioned previously, in the transition environments. And this is another reason why we have clients, as I referenced before, IHI, that is utilizing this type of information or this type of implementation in a highly dynamic and changing environment with both on and off-road use cases. So this highlights the flexibility of the NBL engine and how we can accommodate changing customer requirements without resorting to totally new development projects. I would also add that the part about consultation on NBL, we do a lot of, and it's the sensor that will be utilized. So we are often asked what sensor would be the best, and we then go down a checklist on exactly, operating environment, weather, dynamics of the vehicle, et cetera. So we do specify a minimum performance requirement and also do critical functions for the client, such as timing synchronization, which is another critical factor, and integration support on all their vehicles. So this is just a graphical representation of the reference system architecture. And what I will highlight here is the flexibility, which is crucial in testing and validation. We can accommodate a number of different sensors that the customer may wish to utilize and provide not only the reference measurements for absolute positioning, but also the time sync. Our post-processing software has very specific tools that can be used for sensor calibration. It's kind of the unsung part of the software, that it's not just about the position, which is obviously critical, but it's about all of the LiDAR, QA, QC, camera, or if there's other sensors involved, that we have all of that ability to look at every channel of data and see if it is calibrated right, if something shifted during a test run, or if lever arms were out of spec, et cetera. So all of these things can actually be controlled and even adjusted in post-processing. A little bit more on map-based localization. So there is an online and offline process to this. Typically, what we will do is have one of our position and orientation GNSS inertial systems that is operating in concert with some specific LiDARs. We can use pretty much anything the client wishes, but as I said before, we do have a minimum performance requirement. And we will then do a data collection mission, do the offline mapping workflow, specifically with an augmented version of our POSPAC software, do the calibration, the map generation, and generate that map. It will then be loaded onto a PC or an embedded computer on board the vehicle. And then with the position orientation system, common filter estimation on exactly where we are, the map is used as an adjunct to aid the positioning in real time to generate a full navigation solution. So a little bit more on the production scale positioning stack. In the first slide, as you saw, it was essentially Trimble ProPoint Go with the position orientation system. Now we're just talking about the actual vehicle. The ProPoint Go is hosted on an embedded computer on board the vehicle. The approach is pretty straightforward. It's just about what other ancillary sensors the OEM wishes us to use and how we are getting things like wheel speed, et cetera. But working in concert with the RTX correction stream, we can actually get the best absolute position possible, less than 10 centimeters, and that's a 2 sigma number. Again, I'm not going to go into this in a lot of details. I already covered it. Just the only thing here is the customer at the end of the day is getting a client library, which is then discussed with them on system requirements to make sure that their hardware that is going to be in production for the next 5 to 10 years will host our ProPoint Go library. So the benefits of Trimble RTX and a correction service, for those who are not familiar, in the left, when you're talking about network RTK, you need to set up your own reference system. Now, on things like closed course test tracks, et cetera, that's okay to use because you're not going to be anywhere near 5 or 10 kilometers away from the reference station and you're going to get a decent result. However, when you scale the approach to not just testing, but actual passenger vehicles that will go coast to coast, you need an end-to-end positioning solution that is independent of any base station. And that's where the true value of RTX comes in. It has global coverage. It's meant for high dynamic applications, very scalable and low bandwidth data consumption. So it's a very flexible engine and very robust. In terms of the correction service coverage, it is essentially worldwide coverage via satellite, L-band satellite. There are 2 services, RTX Global and RTX Fast. The main difference is the reconvergence time on the RTX Fast engine. So a brief word on what we mean by integrity monitoring. So integrity monitoring was created specifically for the automotive industry, but it can be used for any other industry that requires it. But the main difference from the traditional RTX streams is that it has the addition of a pre and post broadcast integrity check. So during the pre-broadcast monitoring, observations from the stations are used to validate a newly generated RTX correction, and any faulty corrections found will be filtered out by the RTX server prior to broadcast. The second step of the integrity monitoring is the post-broadcast, where the observations are used again to validate the broadcasted RTX corrections that were received from the monitoring station. So in other words, the post-broadcast integrity check includes the full data transmission channel. And the post-broadcast integrity module is able to send any kind of alarm within that stream when an out of tolerance measurement is detected or the integrity monitoring system is not available. Those integrity alarms and flags are transmitted, and the flags indicate the validity between the pre and post broadcast. And then for the alarms, the corrections are flagged as usable, unusable, and should be or usable, should be limited use, or not usable at all. So those parameters help the users define within the positioning engine the priority of how that correction is used. And this is part of why we take a lot of care in developing a full sensor fusion approach here. If something goes offline, that there's automatically a redundant backup, and everything works in concert, weighs the potential position solution, and then either accepts or rejects. And that goes for either the GNSS, IMU, DMI, or the actual RTX correction itself. So this is just a summary slide, essentially outlining that with RTX, you are getting a very fast conversions time to get you less than 10 centimeters of data, availability of 99.99%, and low bandwidth and global coverage. Just one more, this is just a graphical representation of what I was alluding to before in terms of in an in-lane positioning scenario, for example, you would have the protection level set at 8 centimeters, 10 centimeters, or whatever the lane width is. And then if anything were to supersede that bound, it would either be classified as misleading information or hazardously misleading, and that estimated position then would then be rejected, and then the other GNSS, IMU, or map-based localization data would be used. However, what you're looking at is a very, very, very low percentage of failure rate on the system. When it actually comes to defining what a functionally safe architecture is, so we take a three-step approach. It even starts before the software is developed. So we follow automotive ASPICE software methodologies and design the software to ASIL B so it is industry compliant. The integrity monitoring solution, that is what I just covered off. And for the software safety protection levels, you have onboard and offboard, and the way the software was designed, a multi-layered approach on how we are ensuring that we have the best safety solution that is functionally safe. Just a brief word on performance. Again, with the plot that you're seeing is from one of our test runs, and the test runs are done not only with our test vehicles but also client data. Typically, what we will do is runs of 100 kilometers and introduce a lot of transition environments, as I spoke about before, and then start looking at where we can identify potential corner cases. So the accuracy in near sky conditions is less than 10 centimeters. However, when we actually start looking at position augmentation and other factors, when we rerun these tests, we will do them with the real-time data, but we will also compare that to thousands of other test runs that we've had within the same conditions. Just a brief word on some of our partnerships. As I mentioned before, the recent milestone we hit with General Motors, 34 million miles driven with Super Cruise. But we're also very proud to have recently announced our partnership with Nissan and being on board their ProPilot 2 Assist. And I would say that if you look at all the highlights that we've had, it's really the 30 years and the 15 plus OEM customers that have entrusted us with their business. That is not including a lot of new things that we're doing within the autonomous trucking space as well. And looking at taking this technology not only to passenger vehicles, but to really accelerate the development of fully autonomous vehicles as well. Brief word on the professional services part. The people are really everything. We have. It's not just enough to provide the software or the hardware. We actually go on site with the clients and not only do the site visits to do all the scoping of any project, but also the integration. So it's not only the heritage of innovation, but putting a lot of that experience to work out some very difficult issues that come up on site. And it's that out of the box thinking that really help the client go further and really why they trust Trimble with their business. And as a final word, we were talking about how many people are working with a partner and, what you should be looking at a partner. Well, it's really the decades of real world experience over a number of different vehicle programs. Looking at, is your partner going to give you an end-to-end positioning solution, or do you have to get 3 or 4 different components from 3 or 4 different suppliers and then integrate it yourself? Are those solutions customizable? These automotive life cycles go for anywhere from 5 to 10 years for one product. So things are going to come up. So are these people going to be, customizing your approach and servicing it properly? Safety first approach. What does your supplier mean when they say it's safety certified? Does it have integrity? Does it have the protection levels, et cetera? And is it hardware agnostic, or are you being forced into a decision? And are what they delivering, does it have global coverage, or do you have to buy something else or integrate something else within 3 to 4 years? And with that concludes the presentation.
Louis, thank you very much for that great information and that great advice there at the end. So now we're going to turn it over to our audience for some questions. We already have some good ones here. Let's get into this Q&A. I'm going to start with this one here, question number 3. What is required for mass deployment of autonomous vehicles? Just an easy question to start with.
Number one is that doesn't really get mentioned a lot is the types of sensors that are being used. Right now, there are very robust sensors that if you put a radar, LiDAR, and camera, because all of them see different aspects of an operating environment, if you don't have something that is solid state, low price, high fidelity, then you can't get that on board the vehicle. We take driving for granted because we learn incrementally. The system needs to learn through a lot of real world and simulated miles. But at the end of the day, it's your senses, right? It's your eyes, your ears that are helping you navigate. And if those eyes and ears are not of a certain fidelity, I mean, we could build you an autonomous vehicle right now, but it will probably cost, $300,000-$400,000. Well, not all of us have that kind of cash. So it needs to be and this is why the ADAS systems, what you see are these packages that the OEM sell you that have amazing capabilities, but an ADAS system is an assistance system, not autonomous. So you are ultimately responsible for overseeing the system is doing what it needs to do. So I hope that answers the question.
Definitely. Okay, I'm going to take this question here, question number 8. And it's a question, I'm just going to read it as it's worded here. It says, follow-up question to the cases about unavailability. Does the performance hold in those instances of extended outages?
So the answer is it depends on what sensor set and what the sensor fusion portion of that navigation solution has. So for example, if you just have GPS, open sky, you're going to get, less than 10 centimeters. But as soon as you hit an occlusion or go into a city, you're not. If you have inertial, if you have odometry, if you have map-based localization or other adjuncts to, or the additions to that, then yes, the performance should hold.
Hmm.
It
Great.
really depends on the approach.
Hmm. All right. So, I'm going to do this question number 2 here. What are the most challenging use cases for precise positioning?
The most challenging are, again, always come back to sensors, because if you have a really good high resolution data set, transition environments are not that big of a problem. When you try to do the same thing with a low cost sensor and have it in a dynamic environment, so it's easy to do things in a test course, it's easy to do things when the weather's okay, in a sunny environment. But as soon as you start going into transition spaces with weather effects, with a highly dynamic environment, I would say those are the most challenging ones.
Mhm. Okay, I think we're going to do about 2 more questions, Lewis. Here's a question. I think having that poll at the beginning was a great idea. So it's kind of in the same ballpark. What are the most important questions to ask a positioning solution supplier?
Sure. So the reason why, um, so do they actually have an equipment that is going to, hardware and software that's going to help you at every stage of that development, product development and deployment process? Uh, it's If you don't have all of the tool sets that you need and the people to help you integrate and be a total partner with you, then you have to start asking questions as to how much cost and time to market are you going to have to sacrifice to go and do that route. This is why we have an ecosystem with the personnel to assist clients at every stage of that. So whether it's a reference system, whether it's an antenna, whether it's a chipset, whether it's a piece of code, we have all of that, and it's been tried and tested in a number of different use cases. So is your partner a one-stop shop, or are you going to have to be responsible for integrating disparate parts from a number of different suppliers?
Mhm. I mean, it sounds like, especially from the advice you had at the end, that there's a huge human side and personnel side to this. It's not just, getting on board with technology. There's a lot of human interaction that you're going to need.
Definitely, definitely. And I have to say that the team at Trimble, out of all the places that I have um, worked, Trimble has the best team that I've ever worked with. And everybody has an open door policy. And sometimes the solutions to some technical issues come from the most unlikely sources, because there's such a wide and deep knowledge base at the company.
That's amazing, especially these days. That makes a huge difference. Okay, Lewis, I think we're going to do one more question here. Question number 4. What is the most compelling business case for precise positioning?
So as we get into the advent of um, user and location based services, some companies wish to monetize, monetize data on, locate. Are you going to get streamed a specific ad when you cross, a certain store? Or sometimes it's not even the business case. It's more about the human side of, what the product does. ADAS systems save lives. So it's
Yeah.
about life saving. It's about um, doing the right thing, and making these vehicles as safe as possible.
Yeah, for sure.
That's probably the most compelling business case that we could possibly have.
Yeah, I agree. I mean, you hear so much about the experiences and all the cool, fun stuff like South Park, but safety really is going to be the game changer.
And then with the advent of autonomy, I mean, the main reason I got into it was we had people with limited means of driving, people who were physically challenged or whatever, that said, "Look, this gives me the capability or the potential to actually go do my own shopping or go and see my grandkids or whatever." So I mean, that's a great mission.
Yeah, I agree. I'm excited about those sides of it as well. Okay, Lewis, I think we're just about at the end of our webinar.
Great. Well, it's been a total pleasure talking to you guys today, and I hope you found the information useful.
Yeah, definitely. I think they did. I did. And so that brings us to the end of our webinar. Thanks to today's audience for the questions. If you asked a question that we didn't get a chance to answer, our friends at Trimble will follow up by email. If you learned something from this session, I know I did, please tell your peers about it. The recording will be available in about an hour. You'll find it at autonews.com/webinars. When the webinar ends, a survey will pop up on your screen. We genuinely appreciate your feedback as it helps us create future webinars that are even more beneficial to you. Thanks again to Lewis and Trimble for bringing us this presentation and to you for joining us. On behalf of everyone at Automotive News, have a great rest of your day.